This is the semester one review that we're doing in class. So this is part one. I'm going to put it in two different videos. One covering the problems we did in class on Friday. The second one covering the problems we did in class. First one covering the problems we did in class Friday and Monday. The second one covering the problems we do in class on Tuesday and whatever we don't finish on Tuesday. I'm just going to try to pick the probably a lower stopping point because not all the classes finished at the same time. Okay, first one we did was midpoint and distance. So to find the distance between these 2 points, we have to find the length of this line. We're going to use the distance formula. So distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, the equation again is coming from, we've talked about this several times, it's coming from these two. We can make a triangle. Okay, this is our distance, so this is d. This is x2 minus x1. This is y2 minus y1. Okay, if we make this point x2 y2 and x1 y1. Okay. The distance here is x2 minus x1. So in this case, it's going to be, this is -2, this is 3. -2 minus 3, it's a distance of 5. Okay, this is a distance of 4 and -2, so this is a distance of 6. Okay. So basically, it's going to be 5 squared plus the Pythagorean theorem tells us 5 squared plus 6 squared equals d squared. Okay, or in other words, x2 minus x1 squared plus y2 minus y1 squared equals d squared. If we take the square root of both sides, we're going to get x squared minus x1 squared plus y2 minus y1 squared. The square root of that is going to equal our distance. So this formula is coming from the Pythagorean theorem, and knowing that the base of our triangle, we form a right triangle. The base of our triangle is x2 minus x1. The height of our triangle is y2 minus y1. Okay, that's just where it comes from. Okay. If you have a note card, you have your 3x5 note card, you don't know this formula, maybe it's a good thing to write down on your note card. All right, so our distance is going to equal the square root. We want to pick our 2x values. Okay, our 2x values are -2 and 3. So we have -2 minus 3 squared. Then our 2y values are 4 and -2. So we have 4 minus -2. So the two common mistakes you guys made earlier in the semester. The first one is our coordinate points are x and y. Okay, if you want to make this x2 and y2 and this x1 and y2, x1 and y1, that's fine. But the mistake you guys were making was x1, x2, and then y1, y2. Okay, you can't do that. Coordinate points are x, y. Doesn't matter which one's which, but you got to, the first one's x, second one's y, but this can be x1, y1, or x2, y2. That part doesn't matter. All right. So -3, and the second big mistake you guys make is you don't carry down your negatives. So a lot of you would put 3 minus 2, or 4 minus 2 instead of 4 minus a -2. So you got to make sure you carry down your negatives. Okay. -2 minus 3 is -5 squared. Again, 4 minus the -2 is like 4 plus 2, which is going to give us 6 squared. 5 squared plus 6 squared. Okay, just like we had if we do Pythagorean's theorem. Okay. Third, mistake you guys make. -5 times -5 is a positive 25. 6 times 6 is a positive 36, and our distance is going to be the square root of 61. Okay. If you would have done it reverse, you would have made this x1, y1 and this x2, y2. You would end up with a positive 5 squared and a negative 6 squared, but either way, when you square them, it's going to be 25 plus 36. So that's why it doesn't matter which one you pick as your first point and which one you pick as your second point. If we just want to check our answer, we can check exactly, but what square root is this between, or what perfect square is it between? It's between 49 and 64. Square root of 49 is 7. Square root of 64 is 8. So does it kind of look like this distance is between 7 and 8? Yes, it kind of looks like it's between 7 and 8. So probably have a pretty good answer there. All right, this distance was 5. And this was 6. And this is about 7. Well, it's about 7, between 7 and 8. So about probably 7.9. I don't know. Whatever it is, square root of 61. 7.9, 7.8, something like that. All right. Those are the objectives for Friday. We have another, we got to find midpoint. Whoops. Midpoint. Okay, so our formula for midpoint is xm equals x1 plus x2 over 2. And ym equals y1 plus y2 over 2. Then our midpoint is xm, ym. Okay, so the midpoint somewhere in here. Okay. Right, and we had this as x2, y2, x1, y1. So the midpoint is the average, right? So again, if we pick our coordinate system here, the average, right, this was 5 units long, wasn't it? Oh, this isn't exactly plotted right. That's the problem. All right, whatever. It says -2, 4, and it's really -1.5, 4, but okay. So midpoint is the average. So we're going to take the average of the x value. So what's halfway between -2 and 3? Half is going to be between -2 and 3. Then what's halfway between 4 and -2? It's going to be +1. So we should get an answer without even doing anything of -half or +half, comma 1. Let's see if that's going to be what we get. So we want to take the average of the two x values, which is -2 and 3. And divide by 2. Why are we dividing by 2? Because there are two values. So we're finding the average of the x values. So to that, we add up the x values and divide by how many x values there are. There are 2 x values, so we divide by 2. So our midpoint is going to be -2 plus 3 is 1. 1 over 2. The y value of the midpoint is the y values of the endpoints divided by the average of the y values of the endpoints. So we want to add them together and divide by how many there are. There are 2 of them, so we want to divide by 2. So to find the average of the y values, right, we take 4 plus -2, 4 plus -2, and divide by 2. 4 plus -2 is 2. 2 divided by 2 is 1. So we know our midpoint is going to be 1/2, comma 1. The average of the x values gives us the x value of the midpoint. The average of the y values gives us the y value of the midpoint. Then we can put the x value and y value together in a coordinate point, and there's our midpoint. 1/2, comma 1. Okay. Just do another example because we had it in class. I'll kind of just go through quick using the formulas. Okay. Right. So we're going to get distance equals, again, we want to pick our point. So this point right here is -3, 4. We'll make that x2 comma y2. This point is 5, -2, which we're going to make x1, y1. Okay, so distance equals the distance between these 2 points is going to be x2 minus x1 squared. So here's our x values. So -3 minus 5. Don't forget your negative. Okay, and the y values, we have 4 minus -2 again. So 4 minus -2. Don't forget to bring down that subtraction sign. Okay. -3 minus 5 is going to give us -8. 4 minus a -2 is going to give us a +6. -8 squared is 64. 6 squared is 36. Again, +64 because it's -8 times -8. It's going to give us square root of 100, which is going to give us 10. Square root of 100 is 10. So we have a distance of 10. Okay. We want to take the average of the x values of our endpoints to find our midpoint. Okay, looking at this graph, it looks like it's going to be about 1, 1. Halfway between -3 and 5 is 1. Halfway between 4 and -2 is 1. So we know our midpoint is going to be 1, 1. You don't even have to use the formulas if you don't want to. Okay. But let's just do it. Okay, -3 plus 5 divided by 2. So our x values of the endpoints are -3 and 5. So -3 plus 5 divided by 2. This is a mistake you guys make all the time, is you have a negative sign, a subtraction sign. It is a plus. We're taking the average, so we have to add up the values and divide by how many there are. So -3 plus 5 over 2, which gives us 2 over 2, which is 1. The y values are 4 and -2, so we have 4 plus -2 divided by 2, which gives us 2 over 2, which is 1. So our midpoint is, as we said, 1, 1. So you can use the formulas if you want. If you can just find the middle, looking at it and adding in your head, then that's fine too. Midpoint is 1, 1. Distance is 10. Okay. Segment addition and segment bisectors. So this is our third problem here. We have C, J, and JT. So the segment addition postulate says if we have a point B that's between A and C, then AB plus BC is going to equal AC. Okay, in this case, we have J in the middle of C and D. So our segment addition postulate is going to tell us that CJ plus JT is going to equal CT. J is between C and T. It's between C and T. Therefore, CJ plus JT equals CT. And we know CJ, right? CJ this is segment CJ. It represents the segment. It's the name for the segment. CJ represents the length of the segment. It represents the distance between C and J. So CJ is 5x plus 7. JT is 4x plus 9. And CT is 34. Combine like terms. 9x plus 16 is 34. Subtract 16. 9x is going to give us 18. Divide by 9. X equals 2. Okay, are we done? No, we're not. We're looking for JT. So JT is 4x plus 9. So we have 4 times 2 plus 9 is 8 plus 9. So JT is going to equal 17. 17 is the distance between J and T. We can substitute it in here. 5 times 2 is 10. 10 plus 7 is also 17. 17 plus 17 is 34. So we have a pretty good answer. Okay. The next one, identify. So this was number 3. This is number 4. Identify the segment bisector of PQ. Then find PQ. So line L is the bisector. So a bisector splits the segment in half. It splits into 2 congruent pieces. So we know PM is going to be congruent to MQ. Okay, which means PM is equal to MQ. So these 2 segments are congruent. The bisector, line L, splits the segment PQ in half into 2 congruent segments, PM and MQ. Since those segments are congruent, we know they are equal to each other. So the length of PM is 5x minus 7. The length of MQ is 14 minus 2x. If we add 2x to both sides, let's do it up here, down here. 5x minus 7 equals 14 minus 2x. Add 2x. 7x minus 7 equals 14. Add 7. 7x is 21. Divide by 7. X is going to be equal to 3. Okay. Question wants us to find PQ. Okay. So PQ is PM plus MQ, right? Because M is the midpoint of PQ. We can use segment addition. PM plus MQ is going to be PQ. So 5 times 3 is 15. 15 minus 7 is 8. So PM is going to equal 8. MQ is 14 minus 2x. So 14 minus 2 times 3. 2 times 3 is 6. 14 minus 6 is 8. So this piece is 8 and this piece is 8. Then PQ is going to equal 8 plus 8, which is 16. PQ is going to equal 16. So it turns out that these 2 pieces end up being 17 and 17. Okay, but we don't know that when we start the problem. So the key here is that since we have a bisector, we can set the 2 equal to each other. PM or 5x minus 7 and 14 minus 2x can be set equal to each other because we have a bisector, and that's split in half. Okay, on this one, we can't set them equal to each other because we don't know that these 2 are the same. There's nothing here that tells us that J is the midpoint. So we can't say 5x plus 7 equals, right? We can't say 5x plus 7 equals 4x plus 9. Okay, turns out that would work out, but that's just lucky because of how the problem is. So you can't set them equal to each other. Okay, you have to do segment addition. Next one, angle addition, angle bisectors. This one's a little blurry. It's not you. They wanted me to make it big enough. So it's blurry. Okay. So just like segment addition, we can add the angles together to form the big angle. So if S is a point between the rays OR and OT, then we can add angle SOT with angle SOR to get angle ROT. So if S is between the rays OR and OT, we can add these 2 angles together, angle measures together, to get the whole angle measure. So it's telling us this angle is 4x minus 20. This angle is 3x minus 14. I don't know if we can see it very well. Okay. And then they're telling us the measure of angle R. So this is a Q. RQT is 155. Okay. So since S is between rays OR or QR and QT, we know that the measure of angle SOT plus the measure of angle SQR is going to equal the measure of angle ROT. So 3x plus 14 plus 4x minus 20 is going to equal the whole thing, which is 155. Combine like terms, 7x minus 6 is 155. Add 6 to both sides, 7x is 161. What's that, 23? X is going to equal, so we divide by 7, and x is going to equal 23. Is that what we're looking for? No, the question is asking for the measure of angle RQS and TQS, so we have to substitute it back in. RQS is 4x minus 20, so that's 5 times 23 minus 20. 4 times 23, that's going to be, is that 92? Which gives us 72 degrees. 3 times 23 plus 14. That's going to give us 69 plus 14, which is going to give us 83. So these are going to be our two answers. RQS, the measure of angle RQS is 72 degrees. The measure of angle TQS is 83 degrees. If we add those together, we get 155, which is what we're supposed to get. So we know we have the right answer. Okay. So that's 5. This is number 5. Here's number 6. Find the measure of angle PRS. So they want the angle, the whole thing. But these arcs here tell us that these angles are congruent. So it's telling us that angle PRQ is congruent to angle SRQ. That's what those arcs are telling us here. These two angles are congruent. So if those two angles are congruent, their measures are going to equal. So the measure of PRQ is going to equal the measure of angle SRQ. The measure of angle PRQ is x plus 40. The measure of angle SRQ is 3x minus 20. Okay, let's solve for x. Subtract x from both sides. 40 equals 2x minus 20. Add 20. 60 is going to equal 2x. Divide by 2. X is going to equal 30. Is that what we're looking for? No, we're looking for the measure of angle PRS. So we're going to have to add these two together with the angle addition. Q is a point between rays RT and RS. Therefore, we can add these two segments together to get the whole thing. So x is 30. So 30 plus 40 is 70 degrees. We know this one's going to be 70 because they're equal. Okay, but let's just plug it in to see anyways. 3 times 30 minus 20, that's 90 minus 20, which is 70 degrees. So if each one of those is 70 degrees, the whole thing here is going to be 70 plus 70, which is 140. So the measure of angle PRS equals 140 degrees. So just like with the segments, segment addition is always going to work, but sometimes they don't give you enough information. Like this one, they gave us the total. This one, they didn't. Okay, but since they told us these two angles were congruent with the symbols, we can set it equal to each other to still find x. You cannot set these two equal. For example, if we had 4x minus 20 equals 3x plus 14, okay, we would get, we know 72 and 83, and we know that's not going to work. 72 does not equal 83. Okay. All right, if we solve that, when we had 4x minus 20 equals 3x plus 14, okay, we're going to get x minus 20 equals 14, add 20, we get x equals 34. If we plug 34 in to both of them and then add them together, you're going to get a number that's much higher than 155. Okay, they need to add together to be 155. So since they're not congruent, it's not going to work. You have to go with this one. So only set them equal if we know they are congruent or there's a bisector. If you have an angle bisector, the diagram tells you they're congruent or the question tells you they're congruent, then you can set them equal. Otherwise, you have to stick with this one. Okay. All right, now we have the algebraic proofs. So we have two examples here. Well, let's just do the one. Given xy is 42. And then we have our diagram. Okay, our diagram up here, we have z is between x and y. And then we have 3 times n plus 4 is xz, and zy is 3n. And then they're giving us that xy is 42. Okay, so we want to fill in these empty blanks for what essentially is a proof. So step one here, well, normally you would write the givens, which is all of our information up here, and from diagram. And then step two would be to say xz plus zy equals xy. What is that? That is our segment addition postulate. Okay, z, let's write it, segment addition postulate. Okay, if z is a point between x and y, then xz plus zy is going to equal xy. Okay. How do we get to the next step? So how do we go from this equation to 3 times quantity n plus 4 plus 3n equals 42? Well, we get there by doing substitution. Instead of putting xz, we're putting 3 times quantity n plus 4. Instead of putting 3n, instead of putting zy, we're putting 3n. And then instead of putting xy, we're putting 42. So this is going to be substitution. Next step, 3n plus 12 plus 3n is 42. How did we get that? How did we go from quantity n plus 4 to 3n plus 12? We distributed, so it's going to be distributive property. Distributive property. Okay. And again, it's not what are you going to do next, it's how did you get there. So how did we get here? We did it by distributing the one before. Next step for D, how did we get 6n? We did addition or combine like terms, whichever you prefer. Combine like terms is fine. Or we can do addition postulate, or not addition postulate, just addition. Okay. Then we have 6n equals 30. How do we get that? Well, we do subtraction. We subtract 12 from both sides. So here is subtraction. And the last one, how did we get n equals 5? Well, we divided by 6, so we did division. Okay. Division. So here, if we want to fill in the proof, okay, it's going to be the same sort of idea here. We're going to start with our givens. So we know AC is 21. We know AB is 2y. And we know BC is 3y minus 9. And that is given. Okay. We know the segment addition postulate. Tells us that if B is between A and C, then AB plus BC is going to equal AC. So AB plus BC equals AC. So the distance between A and B plus the distance between B and C equals the distance between A and C. Okay, then we can use substitution. AB is 2y. BC is 3y minus 9. AC is 21. That's, again, substitution. Okay. Addition. or combine like terms, we get 5y minus 9. So addition. Or combine like terms. Add 9 to both sides. So this is going to be the addition, I guess, a additive property of equality. So again, let's just say addition to make it simple. Okay, 5y is going to equal 30. Then if we divide both sides by 5, we get y equals 6. Okay, we do that by division. Do that by division. Okay. I think that's it for the unit 1 part. Yep. Okay. So that is the in-class, the unit 1 in-class review stuff. Okay, if you need the unit 1.